Okay, so this is the notes on equations with variables, right? So these are equations like you see with this one right here. I'm going to cover this one part up here for a minute. These are the equations where we have variables on both sides, right? So we have a 5k here, a 3k here, and they're on different sides of the equation. And they're not really any that much different than the ones where we collect, or move one term to the other side, right? Okay, so here, like when we have a problem like this, the first place, probably the best place to start, is with the variables, the numbers or the constants that have variables attached. Okay, so we have this one here. So the first thing we want to do is decide to either move the 5k or the 3k. Which one do you think is the best one to move? Thomas?
3k.
Yeah, and the reason, you're right, so the reason I would move the 3k is because if I move the 5k, I'm going to have to minus 5 from both sides, right? And then in the end, I'm going to have a negative answer, because I'm going to have 3k minus 5k. So instead, I move the variable that's going to allow me to keep an even or a positive number. So if I minus 3k from both sides, in the end, I end up with 2k, right? So then I'm end up with 2 plus 2k equals negative 6. And then I'm going to do the constants, and move them to the other side here. So then I'm going to minus 2 from both sides. And I'm just doing the opposite. And it's this idea that if I just do the same thing to both sides, then I'm fine. I don't change the equation. But also I'm doing the opposite. It's that symmetry thing, or that, forget exactly the name of the property. But if I just do 2, it's opposite negative 2. Okay, so that ends, then I end up with, this cancels out over here, and I end up with 2k equals these two together, negative 8, right? So you see that? Does that make sense so far?
2k. Oh, that's where it connects.
Okay.
I just went ahead a little bit, so it's like, oh wait.
So, and this is an easy one. So, not an easy one, but it's a pretty straightforward one. I'm going to show you ones that are a little bit harder, okay, in a minute. So then if I want to get k by itself, I have 2 times k, so I have to do the opposite. I have to undo that multiplication. I do it by doing the inverse of it, which is division. So then I do it to both sides. So I divide 2k by 2 to get rid of the 2, but I also have to do the same thing, negative 8 divided by 2. So then I end up in the end with k equals negative 4. Okay, that's my final answer. And what's really good about algebra is you can check your answers. So in the end, you come up with that answer. And I like to check things, and to know they're right. And so we just plug it in. So we take wherever the k is, we plug negative 4 in. So we go 2 plus 5 times negative 4, because that was a k, and then equals 3, and there's a k, so another negative 4, 3 times negative 4, minus 6. Keep going. Then I figure out what it says. 20 plus this 5 times negative 4 is negative 20. That equals 3 times negative 4, negative 12, minus 6, right? Then I do my collecting like terms. So 2 plus negative 20 is negative 18. Negative 12, and this is really going to be, it's going to kind of cancel. It's at 12 minus 6. What we do is we make this change the sign of the number. So 6 becomes negative 6, and then we add them. So it's negative 12 plus negative 6, negative 18. They're the same. So that tells us it's the right answer.
Yeah.
Make sense?
Mm-hmm.
Okay, so that's one example. Let's look at another one now. This one's a little bit harder. This one has a distributor property with it. Same kind of deal though, because if we just look at it, we can see that we have an m on this side and an m on this side, right? But we also have these things in parentheses. And if you remember what we said about solving these equations, oftentimes order of operation gets reversed. So we usually in order of operations, we do, whenever we're doing the problems with no variables in them, we do, inside parentheses first, and then we do, something with a squared or something to a power, and then we do multiplication and division, and then we do subtraction and addition. But with these, oftentimes we do addition subtraction first and work our way back the other way. The only thing that's different, it's still the same as order of operations, are the ones that are inside parentheses. We still have to do those first, okay? No matter what kind of problem we're doing. And here we have 5m minus 3, right? So there's nothing we can do there. You see that? We can't add or subtract 3 from 5m because we don't know what m is. But we can do the distributor property, right? Times 6 by 5m times 6 by negative 3. And on this side, 1/3 times 24m, and then 1/3 times 12. Then, when we do that, we end up with, look, so we end up with 6 times 5m is 30m. And then we have 6 times negative 3, can't forget that negative. 6 times negative 3 is negative 18, so we got the one side done. Then we have 1/3 times 24, and that gives us 24 over 3. When we do the division on that, we get 8m. And then 1/3 times 12 is 12 over 3, it's 4, and it's a positive, plus 4. So then we end up with 30m minus 18 equals 8m plus 4. Then we're going to do just what we did last time, collect like terms. So we're going to do the 8. We're going to do the 8, remember, because we don't want to get a negative number. We could, there's nothing wrong with us doing the 30 and minusing it. In the end, we'd get the right answer, but we'd have to run a negative answer through it possibly, or -1 to get the answer. And it's easier just to keep it positive if you can. Sometimes you can't. But here, so we'll minus 8m from both sides, right? This cancels out. This becomes 22m. We keep the negative 18, and it equals 4. Follow me so far? Okay. So then we're going to get rid of the 18 next to the 22m. We're going to do the inverse again, so it's minus 18, so we're going to add 18. And then to both sides, that way we don't change the problem. It's just a rule of algebra. So if we add 18 to both sides, it's still the same problem, but it helps us cancel out this 18 and be left with 22 on the other side. So in the end, we get 22m equals 22. That's an easy solve, right? But then we just have to get rid of the 22 next to the m so we can have m equal something. So it's 22 times m. So we're going to do the opposite. We're going to undo the multiplication, so we divide by 22. And that gives us m equals 1. Make sense?
Yep.
And then we check it. A lot of people don't like to check it. You should always check your answers. It doesn't take that long. And it tells you whether you've made a mistake. Because if you plug them in and it doesn't work, you've made a mistake. There's a few I'm going to show you that maybe not. But, you know, their answer will come out not like m equals something, but I'll show you it'll come out a different way if there's no solution. Okay, so then we just plug it in, right? 1. So we're going to have 5, it's 5m, so 5 times 1 minus 3 equals 1/3 24 times 1 plus 12. Plug it all in, we get 30 minus 18 equals 8 plus 4. We get 12 equals 12. Perfect. Check. That's right. So we know m equals 1. Okay? Good? Got a couple more to show you, and you'll be good for the notes. Can I go on? Good?
Yep.
Okay. So then there's a couple different ones. They're unique. Okay? So say we have one like this, where we have 5x plus 5 equals this distributive thing over here, 3 times 5x minus 4 minus 10x. So we're just, again, you can see these parentheses, we're going to distribute this out, right? And we're going to get 5x plus 5, that's going to stay the same, but then we're going to have 3 times 5x equals 15x, 3 times negative 4 equals negative 12, and then we just minus the 10x on, right? Just add that on. We got the distributor property that we did. Then we just do collect like terms. This side's already done, but look at this side, 5x minus 12. Does that strike you as something weird at all?
Yes.
What do you think's weird about it?
That 10x was divided by, minus 5.
Yeah. So look, so we did those. We collected the 15x and we minus 10x, right? So that's going to give us 5x. But look, I'll show you something here. So then what's our next step, do you think, to do? So won't we try to get the x's on the same side, right? So we're going to minus 5x, right? But look what happens. If we minus 5x from this side, what do we get? 5x minus 5x, what's that?
5x minus 5x is 0.
0. And 5x minus 5x is what?
0.
It's 0. So we end up with 5 equals negative 12. Is that true? Does 5 equal negative 12?
5 equal negative, no.
No. So this is an equation that's no solution. So some equations do not have a solution at all. So this never equals that. There's no number you can plug in to where this side equals that side. You can kind of see it right here. The 5x minus 12, how can that be equal to 5x plus 5? It'd have to be some unique number. And you might be thinking, well, that can't be equal. And once you solve for it, especially if the x's are the same, they're just going to cancel out. And you're going to end up with one number that does not equal. So you draw a line through it, right?
Yeah.
Okay? So that's a no solution problem. So sometimes you do them and you have no solution. And here's another one, last one. We have, I have these arrows up here. Let me get rid of those. Hold on. I'm going to use my little stuff here.
You're going to get,
I'm going crazy with that. Maybe I can, but I can't find it. What's that?
Okay, so how are you supposed to get, funny right there, how are you supposed to get, like,
yeah, it can't work.
5 into negative 12?
Yeah, it can't. It doesn't work. It's a non, you can't solve it. It's a non-solution problem. Okay, so here's another one we have.
It's like, why don't it's been used?
So we have a problem that's a no solution problem. Wait till you see this one. This one's much better. Okay, so here we have this one. So we have 3 times 2b minus 1 minus 7 equals 6b minus 10, right? So what do you think the first step in this one is to solve it?
The first step is to do the inside the parentheses first.
Very good. So we're going to distribute, right? So we distribute it. So we're going to distribute the 3 to the 2b, then the 3 to the negative 1, right? So we end up with, look, if we do that, we end up with 6b, then 3 times negative 1 minus 3, then minus 7, right? Then we collect these two like terms, minus 3 and minus 7. This stays the same. You can't do anything with it. And look what happens. It's 6b minus 10 equals 6b minus 10. You see that?
Those are exactly the same.
They're the same, right? So then, we would then, if we did the same thing and we canceled, like try to get the variables on one side, right? So if we did minus 6b on both sides, we would have minus 10 equals minus 10. Is that true? Does minus 10 equal minus 10?
Yeah, because even with it.
It does. This kind of problem is called an identity problem. And what that means, it's true for all values of b. B can be any number. B can be 1, 2, 3, 4. It can be 5/16. It can be whatever number. If it's a real number, if it's an integer, you can plug it in there and it's always true. Follow what I'm saying?
Yeah.
So that's one of those. It's an identity problem. Okay? So is that good? Let me pause here.